But the fact that we went with the 701 into the factory meant that we trained a whole new generation of factory people. I mean, Dick did that.
That's right.
And that was tremendously important because after the 701, things really took off in a hell of a hurry.
Yeah.
And if we hadn't had that momentum, that cadre in the factory, we would have really been in a bad way.
Well, we never give the 604 enough credit there. We had a small cadre and some experience with that machine, a couple of years anyway, with vendors and tooling and soldering problems, vacuum tube problems. So I think I probably had 100 people on a 604.
I was telling Frizz and Dick before we saw you in that, if you recall, back in the 604 days, we were having resistor failures in the coolest part of the machine. It turned out these were IRC resistors, which were film resistors on a glass tube. And the reason they were failing where they were coolest is that that's where the humidity was. Up where it was hot and where you'd normally think that they would fail, it was nice and dry and you could put voltage on them and not get electrolysis. So we had to switch 604 production from film type resistors to the slug, Allen Bradley type.
Composition, mud and carbon, yeah.
Well, when we were given the job on the 704, if you recall, those were tough days. The Korean War was the reason for the 701 defense calculator. And where are we going to get resistors to build the model? You needed a defense order, a DO, in order to get anything. And the only thing I could do, the only resistors I could buy on the open market were IRC resistors. And I knew they were no good for what we wanted, but they were the only thing you could get. So I ordered them, $4,000 worth of resistors. And a few weeks later, in comes this box that's about this big, by the $4,000 worth of resistors in that box. In the meantime, I finally found a way to get Allen Bradley resistors, and so we ordered Allen Bradley resistors too. When the box of IRC resistors came in, I shoved it under my desk. I was afraid to throw it away, and I was afraid to keep it. And it just sat there for 2 years while I sweated.
There's a lot of reasons, good reasons for bringing manufacturing. I remember when they released the tape machine to us, for the pump, vacuum pump, they released a GE vacuum cleaner, a floor vacuum cleaner. And an apprentice said, you know, buy the vacuum cleaner, pull the pump out, and use it.
You would have robbed every appliance store in the New York State.
Well, we had a GE rep used to come down there, I forgot his name, and we asked him where could we get some of these? And he'd come back, he said, you know, they're obsolete, we don't build them anymore. Well, finally he scared up, I don't know, several dozen. And we tore them apart, put the machine together. Later on, we discovered Rotron right up the road in Woodstock,
They
New
can make
York.
it special for you.
I discovered them at an IRE convention in New York. Walked this booth, saw those little pumps, and says, my God, that's what we've been looking for, instead of buying a whole vacuum cleaner. And he also released there was a rubber switch, a diaphragm.
Yeah,
We went to Lucky Place and bought rubber baby diapers.
Baby pants.
Baby pants,
Yeah.
and
It was very good
cut
rubber.
them out and
Good
put them on.
quality, good quality rubber for the diaphragm. Yeah, I remember that. Well,
There were, if you want to recall the state of the art at that time, I mean, I think Nat or somebody made the comment that everything was new, the technology was new to a very great degree. Nowhere was it as new and as fragile as in the Williams tube storage. And if you recall, there was a read-around ratio problem. The number of times you could reference spots that surrounded a given spot before that given spot was spoiled.
yeah, they call that spill.
Yeah,
Spill, mud hole, and
flat rock effect.
Yeah.
Well, how to get that read-around ratio high enough so the machine would have some speed, because otherwise, every time you'd refer to the memory, you'd have to regenerate all the spots around it, and the machine would be doing nothing but regenerating itself. And that we didn't really know how to make that memory work fast enough for about 4 months after we started that. I don't know whether you ever knew this or not.
Well, when the memory was first released, it was going to be a 512 raster. And as a matter of fact, we purchased a lot of extra parts. And it was after we got on the test floor in the plant in Poughkeepsie and started working, we found out we could go to 1024.
Who came up with the address scattering scheme?
I've forgotten.
Because contiguous spots were 64 addresses.
Well, that helped. That helped. But, Dave Crawford and I, practically 4 hours every day, would sit in my office. I remember once I had a bad foot, and I used to sit with my foot either up on the desk or in a bucket of water, and he was with me, and we would just simply spend hours discussing how we could improve that read-around ratio. And one funny thing that happened, I remember, Dave came up with a brilliant idea, and he explained it to me. It was very complicated. I said, now wait a minute, no, don't go away, because let me play this back to you, Dave, so that I'm sure I've got it. So I've now repeated it back to him. And when I was through, I looked at him, and he had the funniest look on his face.
It didn't work.
He said, my idea doesn't work, but the way you said it does. I completely misunderstood him.
You had fixed it in the translation?
Jerry, that release was a 524-bit raster.
512, yeah.
Or 512. And when we got the 1024, well, we saved one box.
That's right.
One big box.
I don't think that people knew. See, today, before the company or any company would invest the kind of money that IBM invested in that 701, the engineers would pretty much have to be able to say, yes, I can do it, and here's the way I would do it, and so we didn't have the foggiest idea.
We knew we didn't know how to do it.
We didn't have the foggiest idea that we could make that Williams thing work.
But
there were two basic weaknesses. One was the Williams tube memory, and the other was the use of vacuum tubes to do the logic. And the vacuum tubes were continually failing, and we knew about that from 604 experience. And we knew that with putting that many in a system, there'd be a lot more failures. And it wasn't, so we were really erecting this whole structure on not sand, but mud. And it didn't, those problems didn't go away until later machines, which had transistors instead of vacuum tubes and magnetic cores instead of Williams tube memory.
The Williams tube memory was just awfully, awfully fragile. I remember the bloops, memory bloops.
Yeah, Indian blankets.
Indian blankets.
Yeah, the patterns.
We'd be sitting there looking at these rasters that he's talking about, with the machine absolutely quiescent, not doing anything. And after a minute or two, bloop, the whole pattern would change.
The whole thing.
And we put monitors on the lines. We thought it was surges on the power line. We thought it was radio frequency. Yeah. We thought we spent weeks trying to get around that because the machine never would work with that.
Remember the zapping? We do zapping, electric discharges in the room near the memory. And
finally, God bless him, Bill Logue figured it out.
I remember we had four test cells. Two of the memories were facing Hudson River west of the plant. And along about 3 o'clock every afternoon, those two machines would start to goof up. We found out the sun would come down and glare in on the face of the tubes and cause these failures. Then we put blinds on the windows, and the afternoon we shut the sun off.
This Williams tube problem and CRT read-around problem, this comes up with every group that was working at about that time. It came up with Whirlwind, came up at RCA, came up IAC. Was there some sort of community of discussion of this? No. Everyone was working on their own.
I can go into some detail on that from a manufacturing viewpoint.
Yeah.
Now, he's talking before we got into manufacturing, really. There was little or no. We had von Neumann, by the way, as a consultant.
Yeah.
And John von Neumann would come and visit with Nat and with the people, and he... Every time we'd ask him for his advice, he'd say, boy, you're doing fine, because, he had been working on the Johnniac in Princeton. And he could see the tremendous resources that we were putting on this, the tremendous speed with which we were going and getting the machine designed and put together. And, I think he was really quite impressed. And as a result, became quite humble with respect to giving advice on what amounted to engineering matters. He really never did inject himself as much as I thought he should have. But we just had a very good crew on this Williams storage. This fellow named Phil Fox was the head of it. And as I say, thank God for Joe Loeb, a fellow who is still very active with the company now and in charge of a very significant research program. But he finally figured out that it was the bipolar resistors. We had used big wire-wound resistors for the deflection circuit so they could not be inductive. And so they had a bipolar winding, which is a helix in one direction and a helix in the other direction in parallel. And where the wires crossed, because the double helix, where the wires crossed, there were big voltages, and it was arcing every once in a while. And so the minute we found that, and there was a brilliant piece of deduction on his part. We made a test. Nate Edwards is the fellow that worked on the test, and then finally we replaced the resistors, and it cleared it up. But that memory was always on the edge of disaster from the standpoint of reliability. As Dick says, even when we got into production, there were problems. And the 701A, I had left the project long since by that time, but was when we replaced the Williams tube memory on the 701s with cores. I didn't have any part of that.
Max and I were still there.
Yeah, I guess you did that.
Well, it was inevitable.
And the 705s were all core.
It was inevitable that the Williams tube memory would always be right about the edge of trouble, because if you would refresh it less, then you could do more work. And
you remember your knob. Yeah, you were going to have a knob. Work better, work slower.
works better, or works faster. Right.
That's good. Change the regen ratio.
So we were always trying to make the machine run as fast as possible, but also reliably enough. And these two things were completely in opposition in the memory.
Well, that tube, as far as I know, put us into the manufacturing of electronic components. We were buying them from RCA down in Lancaster.
Yeah, they had bad spots all over them.
Well, we had a tester there and one in the plant. We were trying to ship them from RCA, get some correlation. We just couldn't. It went on for months. Finally, we had good relations with RCA, and they finally said one day, Dick, why don't you fellows build them yourselves? And we'll give you the prints and give you everything. And they sent two tool engineers down there for a month or so and brought all the prints back, some of their tools, built the first clean room in the company, I suspect, and started manufacturing our own.
We had John Little
beginning of the
assigned to design the thing.
Yes.
There were other very tight areas from the standpoint of the technology, if you remember. We used vacuum tubes in that machine, largely as amplifiers and inverters. Most of the logic was done with diodes. And we got into a diode problem, and my memory is too hazy now to remember precisely what that diode problem was.
You and I came up here with Sylvania.
Was that the case, Leaky? Was that wasn't the GE composition case?
No, this was a Sylvania.
The glass.
By the way, it was a problem that they first uncovered on the NORC, because the NORC, if you recall, had started prior to the 701, but they had they didn't finish it until long after we were finished.
These were the glass encapsulated.
Glass encapsulated, and Dave Crawford worked on the problem, and we also had a lot to do with Sylvania. But there was some very fundamental problem with that.
Well, the reason you and I came up here, when we went into production, they all of a sudden forgot how to build them. And remember, they were building them over a drugstore here in Boston somewhere, and then they built a new plant. We went out to visit the new plant. It was in the new plant they were having difficulty going into mass production.
Whatever, but there was a fundamental techno. It was not just a scale-up problem. Prior to that, there was a fundamental, during the engineering phase, there was a fundamental technological problem that came very close to disaster. But fortunately, Dave Crawford and Sylvania were able to fix it up. I remember we were trying the magnetic drums we were going to use. Up until that time, we used to make drums by taking cuneiform wire copper, nickel, iron wire, winding it around a drum very tight in a single layer, okay, and then grinding the wire down to its half diameter.
Yeah, that's
And
what,
that's the way we got a magnetic surface. But in the 701, we wanted to use plated drums. And if you recall, the 650, when it finally came out, long after the 701, the 650 was about 2 years after the 701, it was going to use plated drums too. And the chemists could not figure out how to make the plating stick well enough under the centrifugal forces and the head crashes and so forth. And I remember we had two chemists in Poughkeepsie working on that problem, and they had tried everything they knew to clean the drum prior to the plating process. And maybe at 2 o'clock in the morning, one of them went into the men's room, and here the worker, the cleaner, was cleaning the urinals, and he had this big pot of yellow-looking stuff. And he looked at that and he says, "What's that?" And the guy says, "I don't know, I just use it to clean these urinals." He says, "Well, I've tried everything else, I might as well try." He took some of that stuff and it worked.
But we used the QFE,
pretty strong stuff.
we used the QFE wire on the
On the original.
701.
We had it back up.
Oh,
Yeah.
there's a lot of them, because we did them down the tool room. I used to go down, and the tool makers gave me a bench to sit on so I could watch them grinding this.
Yeah.
But we used,
Yeah.
I think all of them were QFE wire drums.
Yeah.
Maybe
We had to back
few
up
at the
to
end.
that. We didn't dare go
Plated,
later.
I don't know.
The 650 finally used the plated. On the power supply, I remember one day we had a big power supply problem. One of our transformers blew up, and so it was obvious that it was underrated. And so we got on the phone, Dick Sweetland and Mike Portnova and I got on the phone with Sam.
Power Equipment Company,
Yeah.
Gallion, Ohio.
Yeah,
Yeah.
Power Equipment Company. Sam, what the hell was his name?
Guy with the big cigar.
Yeah. Well, anyhow, we were on the phone for maybe an hour and a half redesigning this transformer. And we did it, and I said to Sam Hanley, I said to Sam, "Okay, now we got to get this thing because I've got crews coming in all night and so forth. I want it by tomorrow morning. Can you wind me a new transformer today?" He says, "I'll wind it for you today." And he says, "I'll take it home and bake it in my wife's oven." He said, "But I don't know how the hell to get it to Poughkeepsie." He says, "I'll put it on an airplane." I said, "Don't do that. It'll get lost because, it gets to Newark or something. It'll get lost." I said, "I tell you what you do. Go to the railroad, put it on New York Central, buy an upper berth, pay the porter $10, and tell him we'll have two guys that'll pick it up in Poughkeepsie tomorrow morning." And that's what he did.
I'd never heard that.
Oh, yeah. Well, a few weeks later, I got a phone call. Remember Jay Schnackle? He was the controller.
Yeah.
I'd never met him.
No, he was assistant general manager.
No, he was
plant
controller.
controller.
Originally,
Yeah.
yeah.
He called up and he said, "Your name Haddad?" And I said, "Yeah." He says, "Mr. Haddad, I have here a $75 phone bill from a call you made to Detroit." And I said, "Yeah, what about it?" He says, "We don't make $75 phone calls." I said, "Yes, we do."
Not all at once.
Something like a true controller.
I said, "By the way, if that's got you upset, hold the phone." I said, "You're going to get a bill for a Pullman berth that nobody slept in." And I told him about the trip. But it worked, and we got it there on time.
Remember the trip we took to Erie, Resistor in Erie, Pennsylvania?
Oh, God.
And Jerry insisted with this guy that, he was building pluggable units for the 604 too. We had that experience. To get all of the girls and the assembly people together, put a movie on, slide movie or movie.
No,
slides,
I had
how important it was.
I had
to
written a
solder.
4-page pamphlet on how the girls were doing great work, except they were making cold solder joints.
Yeah, I was about to bring that up.
Yeah.
As Nat talked about tubes being a house of cards because the failure rate was high in those days. Well, that many solder connections in any one device was a problem in itself. And it was a recurring problem, which eventually led us to wire wrap. long before printed circuits came, but it was a constant educational problem within the plant.
Well, he was going to take this whole 100 or 200 people off the job, you know, and put this program on. The guy was worried about who was going to pay their salaries. So
Yeah, I remember I went up to
we had to do that. Too.
I went up to Erie, and we got all these
The
girls.
pluggable unit vendor.
Yeah.
The pluggable unit.
What do you
Yes,
call them?
I got all these women who were doing the soldering
Yes.
and in the same room, and I gave them a big pep talk about how important the defense calculator
We
was.
had a
to the-
slide program with
Yes,
something.
big thing. And I gave them each this pamphlet that I had put together over the weekend on how to solder. I still got a copy of it. And it worked. I said, you know.
Well, they were a good vendor. They had good experience. That's why I say the 604 gave us a running start in a lot of these manufacturing areas. We had vendors set up that were learning along with us.
Yeah.
I remember we were also having trouble getting the right magnetic tape from 3M.
I went out there a few times.
Well, we built a little sub-factory.
In Minneapolis,
guys-
Harry Hours.
Harry Eilers, Harry.
We'd ship it across town and to test it before we shipped it to the IBM plant.
I remember going out there once and we wanted to try a new formulation. This was earlier than the production. And they said, well, it's going to take us a week to build and ship this reel of acetate to get it from where we get the acetate and put the coating on it and then get it to here. I've forgotten why, but they said you just can't ship this stuff because once you have the reel, once you have all this acetate on a reel, and this was a jumbo reel, you can't set the reel down because then the weight of the reel will mash the layers of plastic. So you've always got to keep it up, and so it's not a simple job of just putting it in a box. You've got to build a box that will take the axle of this jumbo reel and hold it up and so forth. You know, it's a big thing. I said, we got to do this by tomorrow morning. He says, you can't do it by tomorrow. I said, even if it takes two of your men sitting in the back seat of a car, each one holding this broomstick that's holding the thing up, we're going to do it. And we did it. We did it. But the thing that I recall most was, you know, the impossible situations that we would find ourselves in and the impossible ways we found to get around those situations. It was just absolutely amazing. Everybody was just magnificent. Just magnificent.
This may be a good time to break for lunch. We do this informally. Is the lunch out there? And bring it in on the table here.
Okay.
And just pick it up and
Looks
grab
like
it
lunch.
and stretch a little bit. And,
Use the leg stretch.
yep. This was very good, very interesting. I learned a lot.
Well, is it what you want?
It sure is. It's on target. I've got a lot of questions.
Good. No, your questions are helpful. I think your questions are very helpful. Because I think we're inclined to run out after.
We need to get over into the other side, that is
Yeah.
customers,
Right,
the maintenance in the field,
right,
things like that.
right. You have one of your little things.
When I sit
Very
for a
expensive.
couple of hours, then I get stiff. Well, it's not like a chair. Anywhere I sit, if I stay there too long.
Well, don't hesitate to get up even while you're talking. Talk while walking.
The kinks come out, but I look quite old for a few minutes. I get up like this, you know. I complained to the doctor, and he says, "You're so lucky." He says, "You're so lucky. Don't say that." I thought Caruso a year ago this next month, and broke cracked two vertebrae, and broke my left shoulder, and a whole bunch of things. That's why when I first get up, I go, hurts like a dog.
Yeah. Well, I guess we're all getting along. I used to jog regularly, but the cartilage in my knees is too thin for that.
You know, swim.
Yeah, I move around that side.
Curry tuna.
They can do it.
Well,
I prefer Florida.
Oh, well, yeah, that's where we're going.
Down there. Yeah. Tried to swim a mile the other day, so that takes care of that problem.
Yeah.
I love your description of
More
how
room.
touring led to what you were doing 20 years later.
The plane you just got it too.
I'll have that.
But it seems to me, I read in what you wrote, that you actually read Turing's article after you started the 701, or did I misread it?
Well, I don't know. And actually, in preparation for this meeting, I was thinking back over
Sort of plane.
over what happened, and I can recall
I guess all of it.
when we demonstrated the 701 to the board of directors.
Yep,
This was.
I gave a speech,
yes.
and in this speech, I referred to Turing's result, not at a
Yes,
board
yes.
of directors level.
Right.
And then so. If I wrote something different, it was wrong.
No, what I wrote in my note is that after you started working on the 701, is when you said, but even that would have been wrong. You actually had read it before you ever got to it.
Well, no, I don't. All I know is that I'm sure now, and I thought of this last night because I remember the board of directors, the demonstration of the board of directors. I know that I can remember what I said there, and I can recall talking about a universal machine.
Yeah.
So before the
They must have understood this.
Well, I mean, I didn't go through any of the mathematics. But I mean, so, clearly, I read it before we got through with the 701. When
Yes.
I did read it, I don't know.
Interesting. Yeah. Well, this comes up in all of these sessions. The building of these machines is an engineering operation, and we always press and ask, well, how much of the theory of Turing, Haddad, Whalen, and so on, Shannon also, ever came in, and it's extraordinary. The stories are, in every case, there's a real problem, and you go about doing the engineering to solve the real problem, and then somewhere along the line, you become aware of these things. Not really.
But you see, all of that stuff you're talking about, the
Yeah.
theory and so forth, went into the fundamental understanding that was in the heads of these fellows who did
Yes.
the architectural and systems work
Yes.
and the programming. And it was all very necessary for that. But it didn't enter the project at a particular time. In other words, nobody sat down and said, okay, now let's read Turing's paper and go on from there. Or now let's read von Neumann's paper and go on from there. These papers had all been read by a great many people
Yep.
and were part of the intellectual base on which their work was built.
Did you happen to know Claude Shannon when you were around here?
Oh yes, it was very interesting that Claude was a graduate student when I was an undergraduate, and when I took the modern algebra, my professor said one of the great beauties of Boolean algebra is that it will never be of any use to anybody. At the time when he made this remark, Claude had already submitted his master's thesis, which was the application of Boolean algebra to switching circuits.
Yes. And as far as you are concerned, the application of Boolean algebra to switching circuits came into your thinking at what point? Into your practice?
Coffee or
I don't know.
plain water.
Well, I suspect it was in. I had a shop at Sylvania that was designing building radar sets for the radiation lab and for the U.S. Navy and the British Royal Air Force.
Yes.
And these. After the war, we had a group. We had to find some use for them, and one of them we got some work for NSA, and I think it was probably the NSA people that I really began to get into this. I mean, they certainly enhanced my understanding enormously. My understanding of Boolean algebra, using it for switching.
Yeah, in terms of the problem that they were working on, or in terms of building the machinery? Because of course their problems are some of them Boolean problems, certainly.
The hardware, the circuits.
In the circuit.
Yes.
In the circuit. Yes.
But you're asking questions about what I thought about 35 years ago.
Right, that's the whole game. That's what the game is. It's very hard to remember indeed. Sometimes, though, the interaction brings things back that you've forgotten that were there.
The problem is that a lot of that stuff, like Boolean algebra, at my end of the game,
Yes.
I'd say I used it from the very beginning, but indirectly. In other words, it was never a matter of a textbook application of it in any way. It was a matter of you understood Boolean algebra up to a point, and when you were designing logical circuits and so forth, you knew canonical forms of things, and you would approach them in a specific way, but you wouldn't actually use the algebra itself. You'd use your understanding, and you'd test things with it. I don't know that Boolean design rules have really entered in until machine design.
Yes.
Part, you know.
Yeah. Done automatically.
Yeah.
Yes.
Well, as part of the building the arithmetic unit of row in month, I had, and then also as a sequel to some of the work for NSA, I wrote a paper published in the Proceedings of the IRE that used switching algebra, Boolean algebra, sort of, to optimize switching circuits, a particular type of switching circuit.
How you doing,
That
Dick?
paper was about what year?
It's pretty hard to get your mouth around it.
A lot of sandwiches. 3 inches.
Oh, yeah.
Why don't we bring a chair up?
You need something to put something
No, I mean
down?
for you to sit on.
Oh, no.
Well, you know, so we can at least chat while we're here.
Oh, yeah, but that's not a problem. I'll grab myself a sandwich. I like to walk around. Stretch a bit too. I can go around a bit.
February '49. That was with Dave Brown, who was part of the Whalen project. And he'd been doing experimental work on it, and I'd been doing theoretical work on it.
Oh, I did.
Yep. Together we wrote a paper that covered both aspects.
Yep.
Oh, thank you. You stopped drinking milk? I remember you kept it in the refrigerator at the lab. Over in the laboratory. He had his own refrigerator, the only guy in the company. That was up in the old Kenyon building, wasn't it? Kenyon up.
Only guy until later, when Moe Avery moved to Kingston.
Oh, Jesus Christ.
He installed a kitchen for himself.
He's retired now, is he?
I think so.
Well, he went to, I saw him a couple of years ago. He went to Tucson.
Yeah.
He must have retired down there
Yeah, he
last
did.
year or something. Yeah, I looked at Walt Sadler died.
I didn't know that.
Walt Statler?
Yeah, just a few months ago.
I don't know.
Stovey told me. I think he was down in Florida. Living down there.
He had quite a consulting business.
Did he?
Coffee business. Offers coffee machine.
Just what was the business he was doing?
Somehow I saw him, oh God, several years ago, I interviewed that. He was a consultant with this company that puts coffee machines in offices, and then he took a piece of the action.
You know, talk about capturing the ambience and state of the art of the day. Why I've been trying to, what I've been trying to do is to build an understanding of where things stood at that time.
Yeah.
Which is a very difficult thing to look back and see. But you know, like things I mentioned, like this business of how do you design a machine? What's the engineering practice that you use? That was really a big departure. As I say, even my boss didn't understand the necessity for a design manual and for having groups split up the way we did.
Yeah.
Matter of fact, one of the more diabolical ideas I had was all of my lieutenants, Frizzell being one, others being guys like Lou Stevens, Max Femmer, Harold Ross, and so forth. There, how many of you? 6?
About
5 or 6. I put all their desks in the same room next to my room.
Yeah.
And the reason was so that they would overhear each other on the telephone.
Instant communication.
Well, you and I had that problem too, that you were, I was at Kenyon House and you were over in the.
Well, you finally came down though.
And so we moved together and had our offices adjacent with a glass window and a door, so you could walk from your office to my office without going through a hall. Suddenly, all the problems disappeared.
We would frequently hear the other fellow talking, and we'd speak up and say, "You can't do that. You can't do that. It gives me a problem." And so you trash it out.
And we started this Coombs College of Computer Knowledge principally to educate the 25 or 30 new people to the company. But when that was finished, we just kept it going. 1 hour every morning. Best hours, the best investment in time that we made. Because that was when I would say, all right, it's your turn, Frizz. And Frizzell would get up and talk about his progress on the machine, what he had done and why he had done it to the assembled group.
Yeah.
And that was another way of communicating where everything stood.
Show and tell sessions.
Yeah, but that was the 701 group.
Yes.
And one of the things I'd like to get into after lunch is the relationship of the 701 group to the other groups. One of the things that impresses me is how many different things there were going on in IBM at about the same time. In NORC, the selected, the SS,
EC.
Yeah, EC,
yes.
the drum, which was an entirely separate project. And of course the 650. All of these were going on then.
Well, a very crucial thing was the card program calculator.
Yep.
Which created a market. Because without that, there wouldn't have been groups of mathematicians who were able to use computers in the aircraft industry and other places where we sold the 701s, and there wouldn't have been people wanting problem solved who were going to these mathematicians. I mean, in other words, a market had to be created before you could actually make and deliver 19 701s. Which is and
they were mostly replacement. A lot of them were replacement sales, weren't they?
Yeah, well, the card program calculator consisted of a 604. 604 had a lot of relations to the 701, but one of them was that it was the computer part of the card program calculator. It was a payroll calculator that you couldn't handle a modern payroll, but it could handle the payrolls in those days, and the card program calculator consisted of a card reader and a printer and a punch and this calculator, and you would do a calculation by putting a big deck of cards with data in one end, and you go and get them out of the other end and wheel them back and put them in again. And the communication was by the cards going through. Yes. But by that means, you could solve partial differential equations, do a variety of very important things that needed to be done.
The guys at Northrop that did that first, wasn't it?
Northrop proposed the card program calculator, and they made a lash-up version of it. And then
there was Lesser and Tobin and
Wooden Wheel.
No, that was them.
The guys came from Tobin.
But they came from
That was Greg, Bernie's brother.
Wheeler, wasn't it?
Woodbury.
Woodbury. Woodbury and those guys. Yeah, there's a whole bunch of very smart guys.
Chair, could I?
Yep.
Excuse me a step across.
Well, but you see, you described the communication in the 701 group that you had all these fellows in the same room, desks next to each other, they could overhear conversations and so on. I'd like to get some sense of the ambience of communication across these groups, between them.
You mean to other projects?
Yes,
Yeah.
other projects. Yes.
But there really,
But that was a pretty standalone project.
yeah, there really was not all that much. We were called from time.
Unless we needed something from that group or they needed something from us, there was very little contact.
Well, a very important part of the communication system in IBM
Task force.
was a bar halfway that was in the mountains halfway between Poughkeepsie and
Rockville, New York.
Endicott.
That's what we want to learn.
Yeah, the end.
And that's where
The restaurant.
when there were problems with engineers in one place using something produced by engineers in the other place, and they wasn't working. Many of the problems were solved halfway between.
There was a conference room over the bar upstairs. We used to,
Gosh, I
or a room.
never got upstairs.
There was a brook ran by the thing, or a river or something.
Yep, the Beaver Kill. It was the Antrim Lodge.
Antrim Lodge.
That's it.
Good.
Yep, at Roscoe's.
I still eat there.
Is it still good?
Still excellent. It's a trout fisherman's paradise.
But you knew what each of these other projects was doing. There was some, I mean, they weren't behind separate compartments.
Well, you have to be a little careful.
I guess it was up to them to catch up with you, Jerry.
The ambience in Poughkeepsie, the culture in Poughkeepsie, was different from the culture in Endicott. And those were the two laboratories. We had just opened up San Jose, but it was like a 10-man or 15-man laboratory. Now,
Oh, is that yours? I guess somebody took my. Oh, there it is.
oh, wait, maybe, no,
Well,
I wanted to get rid of this.
A piece of background to this was the relation between Tom Watson Sr.
Yeah.
and the senior engineer.
That's right.
That is, you want to cover that? Go
No.
ahead.
Go ahead.
The senior engineers reported directly to Mr. Watson, and
This is, let's say, in the 30s and during the war. It was just
and-
beginning to break down about
and
1950.
it was beginning to break down. But anyway, these and Mr. Watson would tell them what to do. They would give ideas to him, and there was a very personal relationship. And each senior engineer had a little
Sweet.
domain, and nobody else was allowed in. The other engineers and their assistants were not allowed in that area, and and communication was not as free as we think
Completely
of.
not free.
Understatement of the whole day.
I see.
Well, for example, when I came to work for IBM, they told me that I had written my last paper. I had published my last paper in a periodical. Well, actually, the one you were asking about before
Yes,
was published subsequently, but it was submitted before I went to work to IBM. And there was within IBM there was not the idea of having seminars where everybody would get together. Well, now in Poughkeepsie we understood about that when we were doing that type of thing, and Coombs College was a sample of it.
Yeah.
But in Endicott there was still this older tradition, and so it was sometimes a little hard to find out what was going on elsewhere.
Give you an example. In the middle of 1953, I left Poughkeepsie to go to Endicott as manager of the Endicott lab. And the first thing I did when I got there was establish an internal technical report structure, which everybody thought was horrible because, that meant that everybody could see what you were working with. And the second thing I did was bring all the senior engineers and their next level together for a big meeting. And what was the school building at that time, IBM school building. And the idea was that one after the other, they were going to spend 5 minutes on their feet telling everybody else what they were doing.
Show and tell.
And you have never, I mean, you wouldn't believe the trauma. Because these people had worked for 30 years with this being an absolutely forbidden way to behave. And some of these men would get up and they would be flushed and perspiration breaking out as they were forcing themselves to do this thing, which just simply was not part of their ethic. It had been so ingrained that they keep secret what they do within their own immediate family. So there was, while there was between Endicott and Poughkeepsie a certain openness at certain levels and between certain individuals, it wasn't as free and easy between Poughkeepsie and Endicott as it was at Poughkeepsie. And the reason it was the way it was at Poughkeepsie was because that was a reflection of Ralph Palmer, who was the Poughkeepsie manager. I mean, he knew that that was the wrong way to run a lab, and he long since at Poughkeepsie initiated a technical report mechanism and had seminars, invited outside people to come in and address people in the laboratory and so forth. And within Poughkeepsie, if you had the time, you could go and visit anybody and they'd be very happy to tell you what they were doing if they had the time. But the real problem was that you wouldn't do this except over a luncheon table, or if you happened to find yourself, with 5 minutes, which was very unusual, you would do that kind of, unless there was some specific reason. Now, there is another mechanism that began to grow up in IBM, at least as far as the laboratory is concerned, at about this time, and that's the task force mechanism. IBM has been described by some of us in the past as being a loose coalition of task forces. But I remember that during the 701 design phase, engineering phase, we were asked to sit with people from Endicott, etc., who were working on the 650 and review their project and report to the management what our views were relative to the direction that that project was taking. And there were 1 or 2 other development programs. We had an increased capacity punch card that a lot of us got involved in on a task force basis. But you got to remember that the 701 group, which I headed, and the 701 group, which Nat headed, were not the only 701 groups. There were, for example, there was a central machine shop that did work for all the development groups, including the 701. There was a group that was concerned with the design of magnetic tape drives and so on. And we got our magnetic tape drives from that group. We worked in close conjunction with them, etc., but they did not report to me or to Nat in any way other than we would negotiate for the equipment that we wanted them to design and build for us. The same with the tapes, and the same with the printer, and the same with the punch cards. Now, I had people in my group whose responsibility it was to take these equipments as they came in and integrate them into the 701. But the fundamental engineering work on the equipment in the first instance was done by other groups.
And then the largest other groups that were concerned were the people that dealt with the customers.
Applied science.
Well, one group was applied science, and then, of course, another group were the actual salesmen that were responsible for the accounts where the machines were sold. And this is a very important part of the whole project. If you ask Jim Birkenstock, and if you sat Jim Birkenstock and Cuthbert Hurd down here to describe the 701 project, you wouldn't hear about anything we've talked about today.
None of it.
And they would say, "Here's what we did,"
Yeah.
and they would describe it all. But it was really important. I mentioned, see, the cameras weren't on when I talked about the.
We don't turn the cameras off.
They were on all the time.
Oh, they were.
And I
they
didn't
go
know
on.
it was why I was standing with my.
That's all right. But go ahead.
Well, what
Say it over.
I want to say is that IBM is a very strongly sales-oriented organization.
Yeah.
And without the ability to sell these computers and then to maintain them in the field, it wouldn't have been possible for IBM to spend what it did on the engineering, and IBM wouldn't have gone along with it. I mean, there wasn't. So this is a very, very important thing, and we had the Applied Science Group under Cuthbert Hurd was originally concerned with programming the SSEC, which was an experimental computer, I mean, a one-of-a-kind computer that IBM built sort of as a contribution to science, and it actually solved a lot. It was for a time the most powerful computer in the world.
That was started in the 40s, in about 45 or 6, I believe.
And then when Northrop came up with the idea of building a card program calculator, why, they were very, very much in the middle of causing it to come into existence and communicating the methods of using it, and going out and selling more elsewhere, and knowing the mathematicians and knowing the managers and the people who controlled the money in the field, so that it was possible to proceed with the 701 program. When before we actually started, the design work, Cuthbert and Cuthbert Hurd and Jim Birkenstock had gone out and they'd visited all the customers that Cuthbert had lined up, and they actually
30 or 40 of them.
and they actually had in their pocket six letters of intent. There were these people agreed that they would buy such a computer if we would build it, and such a computer was what Jerry and I had specified that we could make. But I mean, there was some negotiation with Cuthbert about what was wanted.
We thought we could make.
Anyway, we described what it would do, how fast it would go, what its capacity would be, and how much it would cost. It turned out that it cost a lot more than we thought it was going to cost.
Like double.
Double, yeah. But we didn't lose very many customers when we doubled the price. They stayed right with us.
Now, the Nork machine and the drum, those weren't a somewhat different model, weren't they? They were really intended as a one-of-a-kind, or was that wrong?
No. The Nork machine was started prior to the 701 on a contract with the U.S. Navy, Naval Ordnance Research Calculator. The 701, as a matter of fact, made use of a lot of the circuit work that had been done for the Nork. I'm a very pragmatic engineer. I use whatever I can, to make the thing. And Byron Havens, who was the head engineer on the Nork, had done some very excellent work in circuits, and we used whatever we could of that. And in the meantime, also prior to the Nork, was work going on in Endicott on drum calculators for the national security. These were special machines, usually one or two of a kind, for the National Security Agency. And the 650 magnetic drum commercial machine got conceived in spirit about the time of the 701, but it was very low in priority. It was conceived in the beginning as a scientific calculator as well.
Growing out of the
NSA work.
NSA work.
And,
Well,
and the technology of the
the 604.
SSEC. The engineers were actually the team that had been on the SSEC. It was populated from them. And I talked with George Hawkins was one of them.
Well,
And-
Frank Hamilton.
Yeah, but I mean, George collaborated with me and with others in writing a history of the architecture of the early computers, and it was an eye opener to me to find out just what happened. But they had gone back to Endicott from the SSEC project, and they had no idea of making a stored program calculator out of the 650. It was more like the 604 that they were
That's
thinking
right.
of, but you know, amplified, and they developed the drum technology that we used, and it was actually Steve Dunwell, who with Buck Holtz and I were the people that had been given the tape assigned, the tape process, to consider whether the magnetic tape project, whether that was a threat to the punch card business. Anyways, Dunwell, who would come from the Army Security Agency, one of the predecessors of NSA. I mean, that is, he had come from IBM, and then during the war, Army Security Agency, and they'd come back. And he knew about some of these things, and he insisted that it had to be a stored program computer. And he insisted, finally, they didn't make any progress beating on the Endicott people. So finally, they engaged some group of outside consultants, and they came up with a report, and the report was accepted, which led to making it a stored program computer.
I didn't remember that part.
About when was this? Approximately what year? Did Dunwell come?
Oh, he came right after the war.
Well, the first place, the tape, the magnetic tape project was set up in 1949, and that was what led to the tape processing machine.
But was this? Was
But
this
Dunwell in the 650, I can tell you better by referring to something.
Look, Dunwell worked in a group in headquarters called the Future Demands Department. Okay? Their job was to try to determine what future equipment we ought to be.
He was at IBM then.
He was at IBM. He had been with the Army Security Agency during the war. Right after the war, he came back to IBM, worked in New York or out of New York in this Future Demands Department. He, along with a guy named Dave Rubich, who was his boss back in about 1946, were largely responsible for the detailed specifications of what turned out to be the 604. Okay?
So this was before the summer study.
Oh, yes. Oh, long
And he was
before.
talking about stored program machine?
No. This summer study that Matt is talking about in IBM, I don't know.
No, I mean the ENIAC summer study at the Moore School.
Oh, that probably
That was 46.
46.
Summer
that-
46.
Yeah.
And what I'm trying to determine is that did he start talking about stored program machines before the Moore School study when the material was generally public?
Look, that whole issue of which came first in the stored program area is a very complex one, and I don't know that I'm qualified. All I know is that the SSEC, which was essentially designed in 1946, 1947, had elements of stored program involved with it that were significant enough that the patent office said they predated some of the Eckert-Walkley stuff. Okay? And now,
It's not priority I'm looking for,
No.
it's the connections between the work that may have gone on during the war and the work that went on afterwards, and not just at IBM, but things that you may know about.
no, you'd have to go to Dunwell directly and
Can we
see.
do that?
I don't, sure you can.
He's still alive.
Oh, certainly. I don't know if Dunwell, while he was with the Army Security Agency, was involved at all with the Eckert-Walkley projects.
Well, he has never said anything to me about his work at ASA.
Yeah.
even though at one time I had a top secret security clearance for a project that I was on working on in Washington, he was still completely mum, whereas everybody else would talk.
Yeah.
But one thing I do know is that the Army Security Agency and the Naval Communications Annex, which Ralph Palmer was in, were one of the places that provided the money that kept engineering organizations going. Who were working on logical circuits.
Mm-hmm.
I mean, I had contracts at Sylvania at 47.
Everybody but IBM.
I don't know. I think so. Everybody but IBM. IBM.
I mean, the National Cash Register was the great beneficiary of that work.
Okay. Well, now Dunwell understood very clearly what computers could do, and partly was the work that he and Buchholz and I had done in planning.
Yeah, but you mentioned a year. I mean, see, the work that you don't get to IBM until 1948. Okay? So this stuff that's in the SSEC, in a sense, predated Nat coming in. All right? So now Nat was a great proponent of the stored program principle. And I remember, asking Nat what the hell is this stored program stuff? And Nat spent a half an hour telling me all about stored program. Okay, and that was, I would guess, shortly after you came with the company.
You mentioned NCR. What do you know about that?
Well, NCR took a lot of contracts from security agencies during the war. And a lot of the people from IBM and other places who went into the Army and Navy and were put on security agency type work ended up working in Dayton, Ohio at the NCR laboratories. Palmer was there.
Coombs, was he there?
Coombs was there.
Coombs came from MIT. That's the same Coombs?
John Coombs.
Yeah.
Yeah, I came from Vannevar Bush's shop, right?
That could be, I don't know. I don't recall.
I think it's the same. Maybe two Coombs.
Well, he worked on a drum up in Minneapolis when he was in the Navy.
Sounds like the person.
Okay,
Yes,
so that would be John.
ERA.
ERA.
Yeah, he went
That's-
to ERA.
He came with us from ERA.
But there, like Max Femmer and Phil Fox worked in the Army Security Agency in Virginia, somewhere, where Dunwell was.
Yeah. Well, I can give
Blakely,
you
Bob
the
Blakely.
chronology of Dunwell's effect on the 650 that made it into a stored program calculator. And this is right because Hawkins was there, and then he was a member. He helped participate in writing this paper that I'm looking at notes from. It was in 1949 that this tape. The magnetic tape project was set up, Dunwell and Buchholz and I. And out of that came the architecture of the TPM, which you built. And then he kept circulating around. He didn't stay and work on the machines in Poughkeepsie.
No.
He was always going around talking to everybody and trying to get things straightened out in New York and Endicott and Poughkeepsie. And one of the things he saw was this 650 work going ahead. And it has to be in 1951 that report was issued, which converted the 650 from a calculator into what we now call a computer. Although at that time IBM called all of these machines calculators.
That's right.
But it converted it into a stored program computer.
Yeah.
IBM was very much concerned about IBM thought computers were people and calculators were machines, and it was very important to distinguish.
We never used the word